Hello everyone, today in this video we'll be discussing the second module of software engineering, which is requirements engineering. Here there are three topics and we will be discussing each topic one by one, and make sure you watch this video till the end so that you can score more than 80% marks easily. If you like this video, hit the like button, subscribe to my channel for more videos like this. So without wasting any more time, let's get started. The first one is the understanding requirements. Okay, so inside that the topic is the requirements engineering. What do you mean by requirements engineering? By the word requirement, what we understand is the things which are required for developing something, right? So that is only requirement engineering. It is the process of determining the user's expectations for a new or modified product. The end who will be using the product, the users will be using, right? So what are the requirements of user that will be taken into consideration first? Okay, so there are 7 requirement engineering tasks. First is the inception. That means it establishes a basic understanding of the problem. We need to understand the problem what it is, so that is called as the inception. After that is done, we will do the elicitation. That means proper information is extracted to prepare. Okay, elicitation means gathering the necessary information. The third one is elaboration. The information which we got from the inception and the elicitation phase, we will be making it more clear and more expanded. Okay, and next is negotiation. We'll be negotiating with the developers and the users to what is their requirements and how it can be done to the maximum nice level. Okay, so that is the negotiation, and it is done to identify the conflicts which are present and to resolve them. Next is specification. The term specification means different things to different people. What is how much specifically the person wants, the users end users want, that is the phase where the specification will be considered. Next is validation. The requirements are there in the list. Now which are the requirements which is actually possible, which are practical? Those are the things which is having a review done by the developers and the end users, so that the validation will be done, and none of the requirement should be status unambiguously, means there should be no doubt about what this requirement is supposed to do. Next is the requirements management. The management of the requirement means after once the requirements are specified and the development starts, after that there should be management of the requirements. If any change is required or maintenance is required, or if any damage or the change happens, with the whole system should be there, managed and maintained throughout the life of the system. Okay, so that is the phase of requirement management. So 7 things were there: inception, elicitation, elaboration, negotiation, specification and validation, requirements management. This is done for the requirements engineering, for getting the requirements to the max better level. Okay, after that we have the establishing the groundwork. Once the requirements are established, we need to start the work, right? But the work cannot be started directly because of few reasons. The customers or the end users may be present in different countries or cities, so the communication cannot happen so easily, and the customers do not have a clear idea of the requirements, and lack of technical knowledge from the customer side also affects the starting of the work. Okay, so the few steps are followed to start the requirements engineering. Identify the stakeholders first. Who all are involved in the product? The stakeholder is the one who benefits in a direct or indirect way. Recognizing multiple viewpoints, there should be multiple views for a same product. The user will see it in a different way, the stakeholder will see in a different way, the developer will see in a different way. So those different viewpoints should be gathered, okay, and recognized. Work toward collaboration. The communication should happen between them, and the collaboration should be there regarding the requirements, and the question should be asked, like focuses on the customers and other stakeholders, that type of questions, to gain a better understanding of the product. That is the next set of questions. And the effectiveness of communication, that is the last set of questions. So these questions will ensure that the requirements are much more clearer. Okay, next is the eliciting requirements, which is also called as gathering the requirements. After we have done like how to get the requirements, next we will actually gather the requirements. So there are few types of it. The first one is collaborative requirements gathering. Here we will be following some guidelines by which we will be getting the requirements. So we can conduct meetings, and rules of participation are established. Agenda is suggested. Facilitator will control the meeting. A definition mechanism is used. So by using all of this, the requirements will be got in a collaborative manner. Okay, next is the quality functional deployment. The first one was collaborative requirements gathering. The second is quality function deployment, QFT. So it means it is a quality management technique that translates the need of customers to the technical requirement. So customer will state the need in a plain English, right? We have to translate it to the technical terms. That is the quality function deployment. So there are three types: the normal requirements, which like generally what a app or feature does; expected requirements, that means what better you can do; exciting means the more better than the expected, like what is the highest level you can reach using the requirement. Those three things are defined by QFT. Okay. After that, usage scenarios are defined, how the scenarios will be there once the user starts using, that factors are considered. And elicitation work product means there will be statements, list, and prototypes of the requirements made, like different products. Okay, so this is list record, this is the statement record, and this is the prototypes record, and this is the models, and so on. So those things will be collected and kept for reference purpose. Next, after that is done, we'll be developing the use cases. What is a use case? Use case is defined from the actor's point of view. From the actor means the final user, what he wants to do, that is the use case. Okay, with that product, what the user wants to do, that is called the use case. The first step is in writing a use case to define a set of actors. First, define how many actors are present. After that, only you can define the use case for each of those actors, right? So after that, define a set of events that are related to the actor. So that event and the actor, those will be interrelated. So event when happens when an actor does something, right? So that will be defined. Okay, so a basic safe home requirements. So to make a home safe, what will be there? There will be CCTV cameras, and alarms will be there, and there will be an access to the internet to keep a check of what is the status of the home. And if any error comes, there should be a system admin who will handle all that and reconfigure the systems. And all those things are connected with the sensors which sense the changes and report to the user. So this is the diagram where you have to make the actors here and the events present, and these are interconnected by a set of activities, and those are also interconnected to the system, which is the sensors here. Okay. Next, after doing that, specifying the use cases, we have to build the requirement model. Okay, so a model will be built. Inside that model, there will be some elements. Okay, elements. What are the elements? Elements means by using those elements, we'll analyze the model. Okay, so four elements are there. Scenario based elements means we'll be using use case diagrams to identify the scenarios, what should be done if such scenario happens. That is called as scenario based elements. The elements which are related to class and objects are called class based elements. Behaviors related like state and sequential diagrams is called behavioral elements. And if it is related to the data flow and the control flow, how it is flowing according to the situation and the time, that is called as flow oriented elements. So these are the four elements that come under requirements model. Okay, so we'll be discussing each four in the depth. Those are the important questions from exam point of view. Next is the analysis patterns. Once we encounter a problem, we'll be having a solution made to it, and we'll be using that solution or documenting that solution so that a pattern we will get to know. Like if a similar problem comes, how should we solve it? That is called as analysis pattern. We are analyzing the pattern. Okay, so there are two types of it. The two uses of it. Why we use analyze pattern? Analysis pattern is used to speed up the development, and second, it helps to transform the analysis into a design model. Okay, to create a design model, and second, to speed up the development. Okay, next we have the negotiating and validating requirements. After all of this, we have to still make it more refined, right? So the negotiation phase comes where we will require for a win-win result. Means the developer as well as the end user will be happy with the situation and the result. That is called as win-win situation. This will happen when we negotiate. Okay, so for negotiation, the following activities are defined. How do negotiations happen? Identification of the system or the subsystems key stakeholders. First, get the stakeholders, determine the stakeholders win conditions, negotiation of the stakeholders win conditions. What does stakeholder expect from the system? And once that is established, we'll try to negotiate what is practical and what is not practical, so that there will be a win-win situation for both the sides. And after the negotiation is done, there will be a review happen, which is called the validation of the requirements, so that some set of questions like, is each requirement consistent with the overall objective of the system? All the requirements have been specified at the proper level of abstraction. Is each requirement bounded and unambiguous, means there is no doubt in any of the requirements? This set of questions are answered with respect to the project, and that is the validation of the requirements. Moving to the second part of the module, which is requirements modeling, scenarios, information and analysis classes. Here we will be considering some scenarios actually in real life. How does that happen? Okay, so what is requirement analysis? Requirements analysis in specification of the software's operational characteristics. So in analysis, what we do, we will specify which software we'll be using and what are its characteristics. Okay, for that requirements to get executed, which software we'll be using and what are its characteristics. That is called as requirements analysis. So in requirements analysis, the action leads to one or more of the type of the models given here. It can be either scenario based model, data model, class oriented model, flow oriented model, and behavioral model. We'll be discussing all of them. Very important questions from exam point of view. So the rule of thumb includes focus on the visible problems first, and once you get to know the problem, the element which is present, it should add to the overall understanding, and delay until proper you have understanding. Means once you have the requirements, if you are not clear with the requirements, don't move further. Delay until you have the proper understanding. Next, minimize coupling. Coupling means the dependencies. Minimize the dependencies so that each of the requirements can be handled independently. and be certain that requirement model provides value to all key stakeholders. Okay, value should be there, and keep it as simple as possible. Next, we have the domain analysis. Okay, we also need to have some information about the domain which you are working. So how does that analysis happen? So here, as you can see, there is an input and there is a process happened, which is domain analysis, and there is an output here. Okay, so this is how you analyze domain, by using the inputs and the outputs. Okay, after that is done, you will be modeling the requirements. For that, two approaches are used: structured analysis and object oriented analysis. In structured analysis, you will be using data. In object-oriented analysis, you'll be using UML, object classes, and unified process. Okay, so each element is observed from different points of view. So four views which are most commonly used is scenario-based model, where we will be using the use cases and the user stories. In class models, we'll be using the class diagrams. In the behavioral model, we'll be using the state and sequence diagrams. In the flow model, we'll be using DFD, which is data flow diagram, and data models. Okay, so let's go into the information regarding the scenario based models. Okay, so what is scenario based models? What is a scenario? Scenario is a snapshot of an event. What is happening in the event, that is called as one scene, right? So that is, the whole thing is called as a scenario. In scenario based elements, it depicts how the user interacts with the system and specific sequence of actions that occur as the software is used. So this is the user and this is the system, and once the user uses the system, that is one scenario. How the user uses the system, there can be many scenarios generated. Okay, and whenever the system is used by the user, there will be a set of activities performed. Okay, that sequence of activities also included in the scenario based modeling. Two things you have to remember: how the user interacts and what are the activities present in the process. Okay, this is a three-step process. The first is create a preliminary use case. So once that actor is present, we have to now define what is the scenario. For that, you need to identify what is the use case, how the user is using the system. So how the user uses the system to accomplish the goal is taken into consideration here. So in example of the home surveillance function, what the homeowner is the actor. What can homeowner do? They can select the camera view, request for the thumbnail from all the cameras, display the camera view in the PC window, whatever the camera is showing, that should be shown here. Select a record camera output, replay the output, access the camera via internet, and when these things are the use cases. So let's consider one scenario, which is access camera surveillance via internet. So one system has put the CCTV camera in the front of his home, and that CCTV camera will be having the things recorded, what is happening in front of his house, and that will be accessible in the internet, through the internet, via some device, right? So this is the scenario here: user being able to see what is happening in front of his home via the internet. Okay, so that is the use case. So all the steps from logging to the laptop to viewing the designed means desired camera view, which camera view you want to see in the laptop, that whole process from starting the laptop, from the shutdown phase to the on the laptop, and then put that application where you can see the events happening on the camera. All those things are called as the use case. Okay, so those steps are included in the use cases. After you have defined what the user is and what is the use case is, what is the system is, you have to refine it. Means every time the first list what we make, that is not the final list, right? You have to make additions to it. So refining will happen in this phase. Like for some examples: view the thumbnails for all the cameras. No floor plan is configured for this house. It can be some things can be missing. Alarm condition is encountered, what should happen in that cases? These things will come when we try to refine it. Okay, next is writing a formal use case. After these things are refined, we have a formal information present with us. We'll be writing it formally. As you can see here, we have the actor present, which is the homeowner, and we have the access camera surveillance and configure safe home and the set alarm, and these are all related with the camera. So this is how you write it formally using a use case diagram. Also, we'll be using some UML models, which is very important, and to supplement the use case. Means the use case diagram is present here to add more information. Okay, plus information. To add more information, we'll be using UML models. There are two types. First is the activity diagram. In activity diagram, we'll be having a kind of representation like this, with graphical representation. It will be starting from here. First, you will enter the user ID password. It can be either valid or not valid. Based on that, you will be proceeding. So this case is called as an activity diagram. Okay, we'll be using this also for more information. Second is the swim lane diagrams. In swim lane diagram, the features of the activity are means specified here, and the responsibility is also taken into consideration. Means what event is happening, who is responsible for it. For example, enter ID and password. Who is responsible for doing that? The homeowner. And validate the ID and password. Who does that? The interface of the system. and select the surveillance camera, select major functions, what you want to do. All those things are done by the homeowner. So, and the capturing of the images and the videos, that is done by camera. So this provides a more detailed view of who is doing what, right? So that is the swim lane diagram. So these two diagrams are there, which is the UML diagrams for adding more information to the existing use case. Okay. After that, we have the data modeling concepts. Okay. After that, data means the UML diagram, everything is ready. We'll have to spend some time in modeling the concepts also. Like first, we'll understand what is the concept, then we'll see how data modeling concepts will be taken into consideration. So, what is data modeling? It is the process of documenting a complex software system and easily understood by the into a easily understood diagram using text and symbols. Means there is a complex system here. We'll be understanding this and making software, means I'll be making one diagram which is easy to understand using the text and the symbols. That whole thing is called as data modeling. Okay, converting a complex system to simple text and symbols for understanding purpose. That procedure is called as data modeling. So in data modeling, the most used diagram is the ERD, which is the entity relationship diagram. Here will be different entities are present, like the users and the system, and what is the relationship between each of them. That diagram is called as ERD, which is entity relationship diagram. So here first we'll use the data object, which can be either a person or a car, which has some attributes. That is called as a data object. And data attributes are the properties of the object, like for example the name of the object, the description of the object, and references what it does to the other instance. Those are the attributes and the properties of the object. And what is the relationship between two objects, like for example person owns car. The relationship between person and car is person owns car. It also can be in the other way, car is owned by the person. Okay, so this is the relationship which is defined here. Okay, and after defining the data modeling concepts, we have to use the class based modeling. For example, the first one was scenario based modeling, right? In scenario, we'll be having different use cases. Based on that, the diagram will be made. Here, based on the objects, we'll be making the diagrams, which is the class based modeling, second one. Okay, so in class based modeling, it represents the objects and the system will manipulate. Means the objects which are present and the system will be using the objects here for the processing the events. Okay, so here what we need to do, identify the analysis classes. Means there are many objects present, n number of objects are present here, and we have to divide those objects into specific classes, right, for more easy handling. So that is called as identifying analysis classes. Specify the attributes, like for example the players attributes will be experience, age, height and weight, etc. Define the operations, what does that object do, behavior of the object. And to represent all of these, we'll be defining one class responsibility collaborator, it is called as. And as you can see in this diagram, there are different classes for each of the objects. Like floor plan, this is the class where we have the responsibilities as well as the collaborators which are interacting with the class whenever required. Okay, so those are made here, and this information is called as CRC, which is the class responsibility collaborator. Okay, and this also has the association and dependencies. Association means the relationship between two objects. For example, floor plan and camera and wall. So if there is a floor plan is present, then only camera and wall can be present inside the system. If there is no floor plan present, there will be no plan and there will be no floor. If there is no floor, there will be no camera and no wall. So this is an association between them. Next is the dependency. Dependency means one is dependent on the other. There will be no linear relationship. It is like a server and a client. So client is dependent on the server for the data, and a server is dependent on the client for the questions. Right. So this is the dependency. Association means same level. Dependency means upper and lower level. Okay. Next, we have the analysis packages. We'll be dividing the similar things into different packages. For example, in environment, we can define the tree, landscape, road, and all. And the rule of the game, we can define the rules present, and the characters will be defining who are the characters and the supporting roles and so on. Okay, so this is the different packages we have, so that it can easily be maintained and handled. Okay, the last topic of this module is the requirement modeling strategies. Okay, so now once we have got a basic idea of the scenario based modeling, class based modeling, we'll understand the two more types of modeling, which is flow oriented and behavior oriented. Okay, this is the last two topics. Okay, so inside the requirement modeling strategy we have these two. So what is flow oriented modeling? The modeling done on the basis of a flow. What do you mean by a flow? So DFD is used here, data flow diagram. It takes input, process and output. Okay, if you understand this carefully, you will get to know what it is. So here in the inputs, we have the sensors and the control panel from where the input data is going. and that input data is processed here in the safe home software by using the user commands and the sensor status. After that, some outputs are generated like telephone, alarm, and the display information, and here some other systems are present. So this is a like a flow from the input then process to the output. So this is called as a flow diagram, data flow diagram. Okay. So if you want to make it in more details, you can make it in two or more levels. This is the level 1, and here is the level 2. We are just adding more details to the diagram. Okay. So like that only we have the subcategory inside that, which is control flow model. It is not based upon the input or the output, but it is based on the events. Okay, control flow model is driven by the events. Okay, here we have the control specification present, which specifies how the behavior of the system is. And here is the example for the state diagram of the safe home security function. So control flow diagram can be either state diagram, which is like this here. Here all the things are defined in much more detail, or it can be either the sequence diagram also. Okay, which I'll be discussing in the behavioral model. Okay, so here we have the process specification present. They're specifying how the flows model should be, and the process that appear at the final list of the requirements. Those processes which are selected finally, those specifications are present inside the process specification, or it is called as p spec. Okay, the last one is the behavioral model. Inside this, we define how the software will respond to the extended external events. Okay, when there is an event happening, how the system will perform or behave. That is the behavioral model. So there are few steps present. First, evaluate all the test cases which can be present. Identify the interactions which is happening between them. Then create a sequence between all those interactions and build a sequence, a state diagram, and review the behavioral model. This is a state diagram, and review if this the model is accurate or not in the real life. Okay, so identifying events with the use cases. Here we'll be having some use case like the points of information exchange. Wherever information is getting exchanged between the system and the user, that is called as the point where we will identify the use case, because whenever information is changed, there is some use case happening, activity is happening. Okay, so actors should be identified, event should be identified, and condition should be identified. What are the conditions in which the event and the actors interact? Okay, after doing that, we'll be representing them by two methods. First is state representations. In state representation, we'll be having different states. Like for example, a player can have two types of states: passive and active state. Next, you have the sequence diagram. So the state diagram looks like this. Okay, so here different events are present here, which is connected with the different use cases like logged, reading, comparing, selecting, and how is the transition happening between them. This is called the different states and the transition between them. Okay, and this is a sequence diagram where we'll be having different kinds of sequences. Like once the sequence is there for the homeowner, what all homeowner can do, it will be defined at this same column, and what all the control panel can do, that will be defined here. It will be like a linear format, and the column wise it will be arranged, and the transitions will happen in between them horizontally. This type of diagram is called sequence diagram. So state and sequence diagram describes the behavioral model. Okay, by using this we describe the requirements what are there and the use cases which are present. Okay, so this is all about this module, and if you found this video helpful, please do like and subscribe. Thank you so much for watching, and I'll see you in the next one.